Welcome, everybody. Student pitches. So we have 7 teams. Each team has 5 minutes to pitch their FHIR app. And we start with team 1. This is the mic that I'll give you. Please switch slides on my laptop, just on the keyboard, and I'll give you a sign when you have 1 minute left. All right? Team 1, give them an applause. There you go.
Well, hello everyone. We're really excited to be here and we're really eager to show you our application. But first I'm going to talk a bit about who we are. We are 4 first years master medical informatics, but we all have a different background. Martijn did the bachelor medical informatics, Dilara did the bachelor artificial intelligence, Anna did the bachelor, sorry. Biomedical engineering, I'm sorry. And I did the bachelor psychobiology, and we kind of divided our task for making the application, so we all had kind of a different role.
Can we switch? Okay, so as a team we created MedDash, and MedDash is a generalizable, customizable and fast dashboard. We focused on easily displayable graphs that can highlight trends, patterns and insights, mostly by leveraging the standard resources within FHIR. And our data mostly focuses on the neonatology department at the Amsterdam UMC hospital, where we work with doctors to create some use cases that you can see here. So some management use cases like general ages of patients, and also some clinical use cases like the number of premature birth observations over a time period, which is just some data that they really like to show during a meeting, for example. But of course, it's just our use case, and our dashboard can be used with all sorts of FHIR data.
So now let's talk about the role of FHIR and the importance of FHIR. First of all, we are using the R4 version, that is a standard and mature version of FHIR. Also, we are using the FHIRly server, and we are hosting the server in a web app service in Azure. And to generate the data and mimic the clinical data that we are trying to show, we use Synthea. And finally, thanks to the standardized protocol that we are using with FHIR, it's quite easy to build this dashboard. Thanks to the structure, we can guide the user to select which variables is best for one type of graph or another. So let's see some examples. Here, for example, we can see the management use case. We can select the different type of charts, also different types of resources, and we have for each resource the possible attributes. In this case, we can see how with the medication that this department, for example, is prescribing. Also, the demographics of our patient that we see that is the age is around the 60s. And also we can see that the risk assessment is quite high after the COVID. In the clinical use case, we can also show how the observations on any other type of resource can be filtered by date, and not only date, but also other attributes, not only from the same resource, but also from other resources. This can be also applicable to a patient level or the resource, yeah. And finally, we integrate the ChatGPT API just in case that the clinician doesn't want to skip all these buttons and clicks. You just type what you want to show, what you want to see, and the ChatGPT just with the FHIR standard can translate into this easy way of graphs.
Yeah, and as with any other project, of course, we've learned a lot. The first and main point that we learned is the importance and usefulness of standardized data. We really figured out during this project what you can do once you know what your data is going to look like, and how easy you can make a process which normally is very difficult, also technical, such as showing your data, showing patterns, creating graphs. And we made it so easy that even a language model such as ChatGPT can do it for you. Also, what we found is that creating test data was quite difficult for us. We used Syntheia to generate it, but to actually include patterns which are clinically meaningful, that was quite a challenge, and yeah, it took us quite some time. And lastly, we really learned a lot about working together from people with different experience and different background knowledge. We've all done previous studies before this, and we really had to combine all of our knowledge into this one project, and that really taught us a lot. And having said that, I want to thank you all very much for your attention and your questions during today. We really enjoyed ourselves, hope you guys did too. And if there are any questions, please let us know after the presentations. Thank you very much.
Awesome. All right, team 2.
Hello? Is it? Okay. Hello and welcome everybody. My name is Anja Schwab. I'm from the University of Applied Sciences Upper Austria, and I will be presenting to you our student track project, which is a dynamic clinical trial cohort definition and evaluation with CQL. So let's get started. First of all, I would like to get you to know my team. So we have Robin. It's actually his birthday today, so happy birthday, Robin. We also have Marco at the back end and Ravan at the front end. So we all have our strengths, and we wanted to make sure that each and every one of us can actually show that and bring that into the project. So let's dive right in. So, well, imagine I'm a researcher and I found the cure for cancer. So now I have thousands and thousands of applications coming in with people who want to participate in my clinical trial to actually get that medication out there. But I can't possibly look. So that's where our application comes in, and we can, depending on whatever clinical trial you're doing, we can find those patients for you. So what you can actually include in a cohort definition are things like age, gender, but also a lot of different conditions, because you might be looking for a patient with breast cancer, like in the example that I'll show you later, or you might be wanting to look at the impact of smoking, so you might be looking for patients who are smokers. So you can do all of that with the corresponding FHIR resources. Yeah, so those resources then get translated into CQL, and we have actually a static component that stays the same for all clinical trials. But what's special about our application is that we can actually do a dynamic change depending on, a dynamic CQL that adapts to the criteria that you select. So here you can see a small architecture diagram of what we did. So on this side, you can see all the input that we got. So we used our own test patients that we created for specific scenarios, but we also used Syntheia test patients. And actually today, during the hackathon, we asked other teams to give us some of their patients so we can actually try and see if we can find those patients as well. And that worked great. And we were really, really happy to do that. That was very exciting for all of us. And on this side, you see what our application is actually doing. So we have this dynamic CQL factory that will create the CQL for us with the criteria that the user enters in the UI. So then you create a library, you create the measure, and then you can use the $evaluate measure operation to actually get those results from our server. Yeah, so let's come back to our example from the beginning. I want to look at patients with breast cancer. So I would say my inclusion criteria is breast cancer. I can add as many criteria as I want, but in this case, I have this inclusion criteria. And for some reason, I might want to exclude patients with asthma. So I can do that as well.
And I have a lot of options here where I can just enter all of my criteria. And now let's have a look at what this actually would look like in our UI. As you can see, we can enter all sorts of different criteria. We can add inclusion criteria, exclusion criteria, and we don't depend on any coding system. So you're free to enter whatever your coding system is in there. So we have pre-selected options that are used a lot, but you can enter anything in there. Yeah, we find our patients, and you can have a look at the details and see what other conditions this patient might have, and then you have the option to contact them. So what did we learn? Well, working with CQL is certainly kind of difficult. And as you can see, these are some of the error messages we encountered along our way. And well, you can imagine that we had a lot of challenges to overcome. But there is an amazing community out there who's always there to help you. And you can actually just go on Zulip, ask any question you might have. And there's always someone there who's happy to help you and give you that information that you need. And one last thing is, I just wanted to mention the new possibilities that are going to be in R5, because we did our version in R4. And in R5, it's actually going to be possible to put those parameters directly in a parameters resource and then query your CQL with that. So I hope you got a little bit of an impression of what CQL is actually capable of doing, and I hope that got you very excited. Thank you.
Thank you. Happy birthday. Great. All right. Team 4. Over there. Careful with the cables, not too, yeah.
So hello everyone for our side also. And we are one joint team from Austria. This is the Lucas, he from University of Applied Science in Wien, and I'm from the University of Applied Science from Graz. And we would like to introduce you the PhysioWeb, our base application. But before we're talking about it, please. Okay, Marcel.
So our general idea was therapy ease, to implement the software where specified health technicians or specified practitioners can also subscribe to one application, which is to ease the communication between the practitioner and the clients. So we met up with a doctor and some physiologists from the Landesgesundheitsagentur in Vienna and the SportsMed Austria, and designed a questionnaire where the general data before a meeting with the physiologist is asked beforehand. So there was, our use case was a 70-year-old knee surgery patient, which was asked questions like, how could you step on the foot after the surgery, and so on.
So as you see, we had a really interesting idea, but okay, we have to choose the one because it's going to be too much. And we said, okay, we're going to make the physiotherapy. And I would just briefly explain you how it's the workflow of the physiotherapy. So we have a trigger, like in our case, the knee problem, or any cause, and you have to arrange the appointment with your physiotherapist. At this stage, we have less information about the patient, how he's looking, what's the problems there. We have the first appointment, and there, I think, like in the mostly cases, you have just 30 or 40 minutes, and in this time, you have to explain everything that you have during the last months, years, and even more. Okay, and after that, we have our, I don't know, second appointment. I received the exercises that you're supposed to do at home, because actually that's what the physiotherapy is. It's not about like just to visit the physician. And in the part of the home exercise, actually, me as a physiotherapist, I don't know how my patient is doing. I mean, like, was it good? Do I supposed to change the exercise? I don't know, because when he's coming and how he was at home, how was the exercises? And yesterday I think it was good, but the last week not really. So, and at this point, our goal is to set at the first time one general questionnaire where I'm coming with the questions like, okay, where's your problem? When you feel the pain, what would you like to do? Like we're speaking about the personalized medicine. And after that, we have one repetitive daily questionnaire after each exercise session where you're able to fill out where was the problem or how you feel that. And me, I mean, like also the point that I'm making that at home when I'm truly calm, I have time to think about and not the 30 minutes for my appointment. Yeah, and to the next step, actually, we already tried today to do the condition, to apply the condition, and also we discussed with a lot of people. We would like to do like a medical report or the bundle of the resources that we want to inform our GP. Okay, how was the patient? Oh, and they are furtherly appoints from something new. We need more. A couple of words to the PhysioWeb, please.
So the PhysioWeb application is based on Python and Django. Django is a template-oriented program. It's really cool because you can integrate the FHIR profile with the narratives and all things in the template directly and can display it. So yeah, I would.
Mm-hmm. And oh my God, the shorthand, you don't see it, I'm so sorry. Okay, and here with coming with the role of FHIR, actually I'm dealing with the FHIR like for 2 years, and they are also like this point of the old and new school, how we are building our profiles and resources. And I try all of them, I would say, or mostly of them, but since like months, I'm really in love with the shorthand and everything you can do. So for example, here you can see the profiles for a practitioner and the patient and practitioner and how our questionnaire and question responses are look like. So the implementation of the sushi, so the validation you're having. We have not a lot of time, but if any questions or you would like to discuss about, please come to us. We would like to.
So now our app showcase, here you see what it does look like for the practitioner. The practitioner can can see his patients, which are referenced by the general practitioner. Yeah, he can see in the details of the patient which questionnaires he already filled out, and then that's the side of the patient. The patient sees his questionnaires, can fill out his patient resources after the creation of a user from the practitioner, and see his overview of his details and the questionnaires. So our lessons learned are generally, if we visited the DevDays before programming our app, it would be much easier because the smart and things like we heard in different pitches from you guys was really inspiring, and I could have done the development of this application with other methods really easily, I think so, but it was a great way to view or to program it on non-knowledge at all, because we already we started learning about FHIR this year in our university, and yeah, it was great to work with specialists from Austria, which are really encouraged us to build the questionnaires with them and to implement them. Yeah.
And the last one, I think the sushi, I mean, like I'm coming again to the FHIR shorthand, and I truly need that we need more open sources for the resource. Actually, that was the reason why today I turned my GitHub repository from private to public. So guys, welcome to access it. And to see, and the last point, actually the support from HL7 Austria and also the international community is truly good, because actually we found each other for decision to the HL7 Austria this stage. Thank you again. And Zulip, it's everything you need. Just go there. There are people going to help you, and we're also thank you for that.
Thanks a lot, guys. Thank you. Team number 5.
Hi, and welcome to our presentation about the FHIR content. We are a student group from the Heilbronn University of Applied Sciences, and in this project, we analyzed our 5 resource in a German research context, and we are taking part of the DevDays 23 as part of a practical project since April 23, and we have been only working with FHIR since a few months. Okay, so this is H.P. Miller. He is from Stuttgart, Germany. He is 68 years old. In 2012, he got diagnosed with skin cancer and got treated the following years. And he had a skin biopsy in scope of cancer treatment and participated in a geriatric study. So before we start, what even is a consent? A consent in general is a permission for something to happen or agreement to do something. And in FHIR, consent is a record of a healthcare consumer's choices or choices made on their behalf which permits or denies identified recipients to perform actions within a given policy context for a period of time. And there are 3 types of consent directives in FHIR, and we focused on the privacy consent directive.
Let's continue with the legal foundation. We have the General Data Protection Regulation in the EU, which gives us the right to decide whether personal data may or may not be processed. As a special use case, we have the Federal Cancer Registry Act in Germany. All data attributes are given by law. It is possible to use certain resources and extensions because of the law, and it simplifies mapping data and simplifies also processing. It is not possible to give permission or revoke from this consent.
So another type of consent we have is the broad consent, which, as the name describes, covers a very general spectrum. So the specificities of what study, when it happens, what the data is being used for is not given at the time the subject is consenting. He's just giving his consent for routine data or biospecimen to be used in future research. Now, another type of consent is the study-specific consent. It defines exclusively and explicitly what the consent is being used for, so what research, what time, which data. So once we did all our research, the ethical background, the legal basis, we quickly realized that we dug ourselves quite the deep hole. Reality hit us as a train, so to say.
So questions that came up have been, how do we deal with multiple consents? How does a consent look like once it's revoked, and how do we know it's revoked? How to use the resource to store data, and how to treat the collection of information when no explicit consent is required. Is it still a privacy consent directive?
All right, so we have provisions which describe what the patient or what the subject is consenting to. A possibility to add these would be via attributes, for example, purpose and actor, but we quickly realized that the FHIR codes are not suitable to reflect the extent of desired information. Another option would be extending the value set of purpose and having the context of action in there. The third option was the extension of the consent resource itself with decisions and sub-provisions. Now, if we have a research study and a patient gives his consent for his data to be used, how do we reference this research study? We just added an extension to research study. Now, what happens if, as we've seen before, the subject has a broad consent signed prior? Here, we can reference the consent in the consent resource to show that the broad consent is given beforehand.
So after that, we had a quick recap. Here you can see which questions have been solved and where we might need to do some work. Thank you for your attention, and you might ask questions after the pitch.
Thank you. Yeah, maybe we have some time for questions after the last presentation. Thank you. Team number 6.
Hello, so for the last 2 months we have been getting into FHIR and so on, working on modeling AI inference, for which we have used FHIR to be able to apply this on remote systems for medical imaging. We all are Frederick, Julika and Olivia, and we study medical informatics at the University of Heilbronn and University of Heidelberg. Our project revolves around the use case that we have our physician who has following situation. I have a CT image of Mr. Miller's lungs. I suspect that there's a nodule. To get an accurate statement about the CT image, AI can help him. It can give him feedback by segmentation and by determining the volume. And that's the workflow we've been working on, and we've come up with a solution for transferring that kind of data and echoing that kind of image with FHIR.
All right, now for the role of FHIR. First of all, you need to keep in mind that our application can be used for all kinds of image processing AI. I mean, that's why we used FHIR in the first place. The lung nodule segmentation is just an example for our use case. We have used FHIR resources to structure our information. For the actual AI algorithms themselves, we have used healthcare services. These contain general information about the algorithms and their capabilities. That's important for filtering. More importantly, it references the service request profiles which specify the input data the algorithm needs to work properly. We have modeled our algorithm calls as service requests. That's also the step where the data gets transmitted. And last but not least, we have implemented our result or possibly an error as diagnostic reports. Also, an important point is our inheritance concept. We have AI base profiles for the service requests and the diagnostic reports. And then we have tailored these profiles to match each specific algorithm. In contrast to that stands the diagnostic report in case of an error that can be used generically for all algorithms. Okay, now you can get a little overview of our application. As you can see here, the client can filter or search for an algorithm. Then he can upload images either from his local machine or from a DICOM server. And that's where it actually gets interesting. After that, he will send a service request to our healthcare service provider server. Then the algorithm will actually start processing the data. While it's doing that, it will always keep the service request updated. You can see that on the right. So you can just ask for the status, how far the algorithm has gotten. And when it's actually finished, it will send back a diagnostic report to the client with the result.
Here's a little application to demonstrate how our project using our use case with Mr. Miller and the lung nodule could be implemented. After the physician has chosen his patient, in our case Mr. Miller, one can search for the wanted algorithm. In our use case, we're searching for the lung nodule algorithm. The chosen algorithm is displayed with all the important information. First, the needed input, so the physician knows which modality and body part is needed. And lastly, the output types, in this case, the segmented image, and also the nodal size. One can also see the detailed information, for example, the availability of the algorithm. All the images which fit the criteria, in our case, with the modality of a CT image, the body part, the lungs in our patient, Mr. Miller, could be filtered out of a DICOM server and displayed so the physician can choose the wanted image.
After the image is chosen and uploaded, the AI algorithm would work in the background on the segmentation. The results are displayed, as you can see on the right. One can see the segmented lung nodules in the picture with the red and green circle, and also the detected sizes of the lung nodules are displayed below.
Of course, we have learned about the standard itself and the transmission of machine-readable data through the discussion of FHIR, and so on the field usability of a FHIR resource. For example, which field can be used for what, and the use of extensions. Furthermore, we learned how to handle Forge by modeling our profiles. So if you have any questions or proposal, you can find us on Wova or send us an email. We are looking forward to get in contact with you.
Thank you. And then the last team, number 7. You can click on the next one. Yeah.
Hi. So this is the team. Here is Leo, and I'm Eric. And we are really thrilled to bring you on an exciting journey through the world of FHIR. Our journey explores the impactful role FHIR plays in enhancing clinical decision support for study enrollment. Let's start by painting a picture. The task of manually filtering through vast areas of patient data to meet study enrollment criteria is not only time-consuming, but also demands a considerable cognitive load, potentially diverting the physician's valuable attention and expertise away from patient care. Our new approach uses research study-triggered FHIR subscriptions, sophisticated triggers acting sharply outside the physician's normal workflow. CDS hooks, on the other hand, act as a bridge between healthcare systems and decision support services. Their primary role is to automate the triggering of clinical decision support. The subscription trigger the CDS hooks in a way that the research study then gets processed. Once activated, these perform an automated sweep for patient candidates based on the defined inclusion and exclusion criteria, culminating in a timely notification for the physician. By specification, the decision support guidance is carried as a CDS card. Within our application, we have explored the key improvements introduced in the R5 and R4 versions of FHIR, specifically those impacting the subscription and research study resources. At present, research studies are maturity level 0, indicating an active development stage with ongoing enhancements. We therefore were really curious about how these changes benefit our application. Let's highlight the other crucial components of our FHIR-based project. We leveraged subscription to automate the detection of newly created research studies. We used WebSockets and CDS hooks, acting as an innovative bridging layer within the FHIR framework. Our WebSocket seamlessly integrated the standardized descriptions offered by FHIR. This is channeled into an efficient prefetch using CDS hooks, further enhancing the interoperability and real-time data exchange capabilities. The CDS service is the heart of our retrieval system for patients. There we needed a clear structure for inclusion and exclusion criteria. We were planning to implement CQL to evaluate and define inclusion and exclusion criteria for research studies. Then we wanted to define groups for structuring the inclusion and exclusion criteria population. However, we soon realized that we could not use CQL in R5, so we have fallen back to be using FHIR Search API. The good thing was that in FHIR R5, a reference to evidence variable was added. There we could use more logical operations than in groups. The last component is our CDS cards. These are the crucial output for our system. They provide actionable insights for the physician outside their normal workflow. More on this will be shared in the next slide. If you have any questions about how we model these resources or know ways in which we could improve, we would be happy if you come to us later. So this is the app we built. It is a prototype, but we implemented the full pipeline of posting a research study to our FHIR server and then getting back CDS cards with the matched patient. And also, if you have seen that, here is a link. This could, in theory, be a question and answer by HelpGPT, our own FHIR-based chat web app for looking up the information used in the clinical trials and ask about questions about underlying literature used in the trials. Well, we have many lessons learned. The limited support for SQL and subscriptions at the moment of creation, for example. We found HAPI did not fully support R5 subscriptions. For instance, WebSocket resource sending this app was not available to our knowledge by now. This led us to devise an intermediary function as a workaround. We found an active GitHub issue that might be of your interest. Then we had the differences between R4 and R5. R5 marked a shift in complexity, structure, and extensibility for our research study. And R5 was less dependent on extensions and more structured with well-defined fields for capturing study specifics. The new model offered greater flexibility in study design, classification, and tracking progress. R5 version had also improved features like the progress status field, which is particularly important when using result data later. However, R5 could potentially conflict with R4. Understanding the limitations and possible selection choices between these two versions was a crucial learning experience. And we had the learning for the inclusion and exclusion criteria specifically. R5 offers more opportunities, more flexibility in designing search queries for clinical trials using the evidence variable. The evidence variable changes provide greater flexibility, as said. And it is really exciting to see that there's a current rollout question in FHIR, which might lead to further adoption of the evidence variable. In conclusion, we took away valuable insights from our experience and eagerly anticipate the continuing evaluation of the FHIR specification. Thank you.
Thank you. That was awesome. I think we're out of time, right? Or do we have time for questions? No? All right. Thank you. So can we? We have enough time for questions for all of the teams. Right. Is there a burning question from someone? Or I also see there's something in the oh, Graham.
I'm sure I speak for everybody, but what awesome work. Yeah. Incredible.
All right. No questions? I see there's something in the chat in Zoom. I don't know if there were people online. Oh, okay. Question over here. Yeah.
I think the team who have data segmentation about AI. Actually, my graduation project is this, and I need to just know
So
how to do this.
the question, yeah. So the question was in the implementation in AI implementation of a group, how they did that.
How you can make the AI make a segmentation, because actually when we talk with professors or doctor, we just go there and ask him. She said like we work in pathological cancer, and she say if the whole image, if you know the whole slide of pathology, we need to segment every part as a region to know which type of this cancer. It's hard to just make an AI design the segmentation.
Yeah, I can admit. I mean, first of all, we can like get together after that and maybe try to figure it out. But what I have to say, I see the problem in that. We have focused more on the communication between the client and the algorithm, and not specifically on getting an algorithm to work. So that would be basically the next step. But yeah, modeling the FHIR resources is more for communication than for actually getting a result out of the algorithm.
You have time for one more question? All right. Anyone? Maybe the jury? Wait, the mic.
So, yeah, I guess there'll be some conferring, and then later on we'll find out.
Yeah, is that because we're... No.
Yeah, so on the one hand, I like to refrain because I now put groups on the spot and either in the spotlights or I just throw them in front of a bus. I was just triggered by the two groups working with CQL, one group apparently struggling and the other group turning away from CQL to the search strategy. So my question would be, and I would like to organize a debate between the two groups, is CQL obsolete before Plateau?
Yeah. Oh, that was true.
I can quickly answer that. We actually talked to the other group during the hackathon because we were both very, very curious what the other team did, because we just read the description and we were like, oh, what are they doing? So we actually found out that the part that is missing for them is exactly what we did. So a combination of the things that they were working on that we were working on is actually what would make the project even better. So like, a combination of that would be amazing, because they've been struggling with some of the things that actually the CQL is solving, and their framework is great for everything around that. So yeah.
Great, thanks a lot.
Over here.
Yeah, so I represent the other group. And you are absolutely right. And I think CQL will, of course, still be important. It was just the case that we used R5, and there was no support actually. And this was also our story. Like, we started using CQL and R4, and then switched to R5 to explore more and newer capabilities. Yeah, thank you.
All right. I don't know how we're doing with time, but if we have, I'm looking at you, Steve. 5 more minutes, so if there's... Okay, well, there's more questions, so we can just...
I have a question to all the groups here. You've been now doing work with FHIR and the FHIR standard. Are those assignments that you now did the first contact with FHIR for your teams? Or is this part of FHIR and standardization and doing projects with FHIR? Is it part of your standard curriculum at the university?
Anyone who wants to answer it? Yeah, behind you. Yeah.
So I can answer for the people from the US Technikum Vienna. We had one lecture in the first semester of programming, and this semester is just generally about standardization. We were talking about V2, CDA, and FHIR. And it's kind of the first contact in actually implementing it. I don't know if, no, like kind of. So we have like tiny, well-prepared programming projects that we have to do, but like they're kind of good prepared so that we actually have the resources to do them. Maybe some of the German people also want to answer.
So we, like, technically we had no experience with FHIR. We know what HL7 is, HL7. And what FHIR is and what FHIR does, but just theoretically, like actually looking into it, never before.
Great job. Great job. Yeah.
I have one question for the students. How many of you are looking forward to coming to DevDays again next year? Awesome. Thanks, everyone.
Thanks a lot. Great job. And thanks, everyone, for coming to watch the students pitch their apps.